So this is the touchscreen I use for controlling my shop smith, it happens to be, but so I've got lathe, bandsaw, various functions on there. I've added the one for using the router lift, and you can see I've got various buttons on here: lift up, lift down, stop, or I can move in 10mm, 1mm, 0.1mm steps, and I've got just off to the left here the switches that actually turn the router on and off. So turn those on and off. Just while I'm on this, I can also turn my extractor on and off here, which links directly to the... saves me trekking across the workshop, and that plugs into the fence when I'm using it. I do have the spanner on the side here on magnets. Let's whip that off for the moment. Pause at that point and look at what's going on top. So one of the reasons I built it was to make it easier to do things rather than have to grovel underneath. So I can easily remove that, bring the lift up to the top position. It's not the fastest thing in the world, but it's fast enough for me. It's certainly easier than me grovelling underneath and trying to push the router up physically and then lock it in position. So I can bring it up to the top. I can easily get my hand underneath and lock the thing, and then the spanner fits on easily to change bits from above the table. Take that down again, let that go down. Then I can bring it up in steps of roughly a centimetre, slightly more, or a millimetre, or 0.1 of a millimetre up and down. When you're doing that, you can set a maximum depth that you want to make a cut, and then creep up on it. So let's say that was the maximum depth I wanted to cut. I can check the height of that using something like this, sort out the height I want, and then underneath here I can set a limit stop, so that will then be the maximum height. Instead of coming all the way up, it will stop at that point, and all I have to do is push a guide up underneath here, and I can hear it click when it gets to the right position. So let's just bring it up a bit now. So I can just reach under the table and lock that off to a position. You'll see that when I turn it upside down. So what that means is then I can take the thing down again, I can do them repeated passes, putting a piece of work over the top, and when I come back up I can come up in whatever increments I want. So make one pass, bring it up a bit, make another pass, taking off as much as I want each time. When it gets that maximum depth, it will automatically stop, so that I can get repeated accuracy at a set depth. I just pause there, I'll flip it over and show you how it's working underneath. So what's under the bonnet is one of these incline motors from a Treadmill. This one is a UK one, so it's 240 volts, 0.7 of an amp. You probably find that in America you'll be on half the voltage, twice the ampage. And you can see here this one's got a throw of 4.49 inches. The one I'm actually using is much lower than that, it's about 3.25 I think, which is enough. What you'll also notice on here, it says there's a 900 pounds push, and believe me, there really is. It will shatter anything. So the inputs to this, there's a common neutral, which is the white wire going in there. There's then an up and a down wire controlled by relays, in this case from an MC 2100 board, but you can just turn those on and off manually if you want. There is also an output from the motor section here, which I'm not using at the moment, but it gives a pulse once every rotation, so you could use that to measure the exact position, but I've not found that necessary really, so I've ignored that for the minute. So if I just put that to one side, and if we have a look at what we've got on here, rather than just feeding that in directly to the motor for up and down, I fed it in here through some micro switches. There are 3 altogether. So if I take it all the way to the down position, what I don't want the thing to happen is that the whole thing pushes itself apart, and with 900 pounds of thrust it certainly could. So I've got a micro switch here that cuts out the power, although the controller is saying keep going. It cuts out the power and stops the thing safely. Similarly at the other end, if I go up to the highest position, where you saw me looking at how I could change the bit, you can see it's going up to there and it'll hit this micro switch, and at that point it'll stop. And then it's safely stopped. Now I'll turn it round and show you the other side where I've got the limit switch so that you can control the depth of cut. So this is the micro switch which was controlling the maximum height. So when I bring it up to the top, that's what cuts it out. But I may not want to bring it all the way to the top, so I can use this one, which is just mounted on the depth gauge from the original router. That's how that is the maximum height. Then that one will cut it out as well. So those two are just wired in series with each other. So if I now run it up, you see it keeps going until that switch is activated. And that's what's controlling the maximum height that I can come up to. So that gives me repeatable cuts working up to that level. So the whole thing works pretty well. Now at the moment I'm controlling this using the touch screen that you saw. But that's not the only way of doing it, obviously. You could use just switches, I guess, or relays. But because I've got the touch screen in use for controlling other functions, I thought I might as well add it to this, and then it gives the added controllability of setting particular depths. So these are the components. You can see that basically it was bits of 18mm plywood cut out, spare nuts and bolts that happened to be lying around, and the vertical square section you can see was rescued from a treadmill, complete with bracket welded on. So it's fairly easy construction really.